Hello and welcome. My name is Benny Jørgensen. In this video, I'll be guiding you through what software development is. Developing software is divided into two parts. The first part is a thinking part. This is where we decide what the program should do and how it should store its data. The second part is the doing part. Here we are coding the program from what we have modeled. In this video I'll be using a story. It is a bank. We all have a bank account and we all have withdrawn and deposited money into this bank account. So it's something we are all familiar with. The first part is a scenario. A scenario is a short story telling us how the user interacts with the system. You can think of the scenario as a camera observing how the user is using the system. It is written in clear text. You can use examples. It's mainly observations. The first scenario here is Leah. She has just got a job and wants to open a bank account for her salary. We have all the information we need here. Social security number, address, and how she uses this account when she has it. In this next scenario we have Luke. Luke has also gotten a loan. He wants to buy something, so he has borrowed a lot of money from the bank. There's a little more details in it, but otherwise it's pretty much the same. Today's last scenario is of a bank employee who has a job to do once a year. We have described it as well. When we have the scenarios, we can change them into use cases. A use case is a more formal description of a scenario. A scenario can stretch from days, months, years, while a use case is something you can do in one workflow. In this case, a workflow is something you can do without taking a break. A use case contains a short descriptive title, a short descriptive text, an actor, which it could be a user, customer, administrator, employee, and what triggers this use case. Our first example is open new account. Here the trigger is that a customer wants to make a new account. Here we have two use cases that look like each other. The one is withdrawing money and the other one is depositing money. In this case we have an error scenario as well. In some cases we want to describe both a success and an alternative if something goes wrong during the use case. In this case, if we have entered a wrong account number. The last use case here is triggered once a year when an employee has to print out the account summary. In the scenarios we had lots of data. Here we are looking at all these data. These data can become objects in our system. Some of these objects are not objects that we are going to use in this part of the modeling. Yes, there is a bank, but our system is intended for this bank, so we don't need lots of banks, and we don't have any additional information on it. Also, we don't care about the burger, the dress, and whatever they are using their money on. Equally, we don't care about the employee. And the account summary, we don't use it this time as an object. This is more like a function. When we have sorted out the objects that we don't want to model on, we have this. We can see how these are connected. It makes sense. We have two users, Luke and Leah. Luke has two accounts, a loan and a salary account, while Leah only has one account, her salary account. We can see that Luke has made his account at the 5th of August and that he has got a paycheck on the 1st of September and that he withdraws $120. We can also see his loan at $100,000, and the same with Leah's salary account. We can see that she got paid and she had expenses. Basically, we had three kinds of objects. These will become classes. We have the customer class where we store Leah's name, social security number and her address. we have the account with an account type, if it's a loan or if it's a salary account, and we have the account number. And then we have what I have decided to call account events. These are money getting withdrawn or deposited at the account, and the date where it happened. We did throw out the bank, even though it was mentioned. Now we are thinking of it again. That is because we are using the bank as a data class. We want something to hold all our customers, all our accounts. Also, we don't want code to make user interaction put into our domain. Our domain model is our problem area. That is our data, and we don't want user interface in there. So we need a class for that as well. What we can see here is that our program will consist of more classes than our domain, and that's okay. We can formulate that using the class diagram. Here I have entered 2 more classes than in the domain model. We can see we have a user interface, we have the main, that is the main execution of our program. We have a print menu, we have a select function, we have create new customer, create new account, withdraw money and deposit money. Then we have the bank system. The bank system is a class that's taking whatever is entered in the user interface and do something with it in our domain. In this case we have create new customer, create new account, withdraw money and deposit money. The same methods that we had in the user interface. These 2 classes are unaligned. These are static. We only need 1 user interface and we only need 1 bank system, and therefore we are making the classes static. Let's start by making a new program. We'll call it bank demo. Let's start by making the account event like that. We don't need all this. I'm making 2 properties, one for money and one for the date. To make it a bit easier, just put in the date as a string. I had made my setters private, so they can only be set from within this class. When we have made an account event, we don't want to change it at any time. The data will be entered through our constructor. If this was a real system, the date will probably be set in here, not through the constructor like this, but as something like this. But we set it in the constructor, and then we can make the date appear just like we do in the domain in the object model. The reason why I'm making it using strings and parameters in our constructor is that we want to enter the data that we have in our object model. The next class we want to make is the account class. In the account class we will be using a list, but let's get rid of all the other usings. Again, when we have set the type, it will never change for an account. Like the type of the account, an account number can also never change. If you want to make it easier on yourself, remember to initialize all your lists and other stuff in the constructor. Can you remember from our domain model that every account has at least one account event? The way we want to ensure that an account has at least one account event is to put it in the constructor. We need a date and the money. This way, whenever we make a new account, we will make a new list, remember the type, account number, and enter the first event on that account. For security reasons, the lists are a private. We don't want anybody from outside the class to access this list. Then we have to make some kind of arrangement to add new events to this list, and we do that through a method. Just like that. We all know that an account has a balance. We want to know how many money we have on our account. But we don't have a balance property. So what do? We calculate it. We have all the information we need. We just have to go through every account event on this account. So let's make a method that calculates the balance. Now we have the account event and an account. The next thing we want to do is make the customer class. A customer can have 0 accounts, you can have many accounts. So we want to have a reference to all the accounts. We want to store the customer's name, and we want to be able to change it later if he changes his name or her name. On the other hand, a social security number is something that we never change. A customer can move, so we must be able to change the customer's address. Therefore, not a private setter here. Remember to initialize the list. That was it. Now we have implemented the domain model. Now we know how to store the bank's data, but we cannot use the domain model yet. We need some more classes for that. The first class we need is a class to communicate with the domain model. And for that purpose I have chosen to call it a bank system. Let's create the bank system. We only have one bank system and therefore I'm making it static, just to make it a little bit easier. There are design patterns that are better than making it static, but for simplicity in this demonstration I'll make it static. When I make a class static, all its content has to be static. Instead of a list, I'm using a dictionary. A dictionary is a little bit the same as a list, but instead of looking it up each one at a time with an index, we'll look it up here using a key. So we need to mark a key and the data. In this case, my key is my social security number and the data is the customer. We don't want two customers in our system to have the same social security number, so let's check that the social security number that we have entered are unique. I have to remember my own naming conventions. Again, here we can see that dictionaries are a little bit different than lists. It starts by asking us of the key we talked about, that was the social security number, and then we need to enter a customer. We don't have the customer yet, so let's make a new customer. IntelliSense of Visual Studio is helping us, telling us that the first thing we need for our customer is the customer's name. Next thing is the social security number. Here you are. And then the address. I put up this method returning a boolean, and here we have a success, so I'll return true. If we had the social security number of the customer, we would return false, not adding a new customer. Like that. We can now go back to the program. It is called the program here. But to show you that in our case this is not just the program, it's the entire user interface, I'll rename it to user interface. Whenever we run our program, the first thing we run is the main. And we'll be running here. When we are finished running in the main, our program will terminate. So let's make a loop so we can stay in here while we are running the program. We want to run the program at least once, so I'll be starting with a do while loop, and I want to run as long as the stop program is false. In here we want to print out a menu, so we can select whatever we want to do. Like that. And we need something to select from the menu, not only printing the menu, but selecting from it. Something like that. Let's start by making the print menu. We'll be having lots of menus in this program, and therefore I'm starting with printing the top menu, as it will be alike in all the menus. Now we have a menu, but we also want to have a select so we can do something. The read key reads one keystroke from the keyboard. Here we transform this key with lots of extra information into a single char. It is a char and not a string, and therefore we're using those and not those, as in these would give us an error. Now we can select stuff from our menu. We're using the switch to take in whatever we have touched at the keyboard. And if we have touched a 1, it will do create new customer. If you have touched the 2, it will create new account. Each time returning false, as we don't want to stop our program. Remember, up in the top here, we are running for as long as our select from menu doesn't return a true. So we'll continue while it's false. And in number 5 here, you have selected end program, and therefore we will be returning true. What we'll just need to do now to create a customer is to create the method of creating a customer. Remember that social security number was an integer. But we cannot do it this way. We have to parse it. A console read line will return a string. A string and integers are not the same, but we have the int.parse that can convert a string into an integer. But what if somebody types in a name instead of a number? Then we can't parse it. We have something that will catch this. It's called a try catch. You try to execute some code. If it doesn't work, you'll end up in the catch. It's fairly simple for this state. So just look here and I'll talk you through it when I've written in the code. At first, remember the scope rule. I cannot define an integer in this scope and use it outside, so I have to define my social security number integer outside of this try catch. Then I'm making the try part, saying that I wanna try to convert the string the user is entering here into an integer. If it doesn't succeed, I'll print out the error message and returning a social security number that is negative. I have used negative here because it's not allowed to have a negative social security number. Before I create the customer, I want to check that the user of this system has entered legal information here. So I want to check if the name, is there something in the name, is there more than 0 characters within the name string. And are the social security number bigger than 0? We saw that if there comes some kind of an error, it will be -1. If the input seems correct, we accept it in here. Otherwise, we are printing out that there was something wrong. Now we think that our input data are correct. We'll try and run the lines of the program we created earlier in the bank system class. We can see again that IntelliSense is helping us, telling us what to enter. The name, social security number and the address. Entering a new customer can go wrong in lots of levels. First of all, we can enter invalid information. This is a very simple check. But we could also try and put in the customer that was there. Therefore, we are selecting the success and saying that if it was a success, we want to tell somebody about it. Else it... Oh. I think we are ready to test it. So we'll start out by running the program. Our main menu is working, and we know that all we can do are create new customer. You have selected create new custom, enter customer name, Lea, social security number, address. New customer created. Let's try and create a new customer again. This time we don't want to enter the input. We can see here that empty string as a name, no social security number, an error has occurred, and then something in Danish, depending on the national settings of your computer. Enter new customer address. Didn't leave anything there. Not all applied information was correct, so no customer was entered. Let's try and enter another person. Customer name, Jesse. Social security number, the same as Lea's. Address, here. We have entered all the information. New customer was not created, so the social security number was in use. Let's try it again. Jesse again. A new number. And she's still here in my basement. New customer created. The only functionality we are lacking of testing at the moment is, can we stop the program? It looks like that whatever we have implemented is actually working at the moment. The next part is to see if we can create an account. Let's grab what we can use here. We needed to enter social security number, like this, and account type. We can reuse this part at least. Remember to be lazy the correct places. Create new account by type. Yeah, and there were some more information. I can remember that. So we want to apply all the needed information, like that. So whenever we want to create a new account, we must enter a social security number in order to find the customer we want to create the account for. A default balance. If it's a salary account, it will probably be 0, but if it's a loan, it will be 100,000, for example. An error occurred if we couldn't pass it. Again up here, if the social security number wasn't able to be passed, an error occurred. Then we can type in the account type and a new date. All we need to do now is make this method. So the first thing we need to do is find out, does the customer exist? We can copy that from up here But it's a little bit different this time. Here we wanted to return true if the customer didn't exist and we made a customer, otherwise false. And here we want to return true if the create new account was a success, still true here, false if we come down here. But we want to remove this negation. We want the customer to exist at this point. And we don't want to make a new customer. We just want to find them. And we can see here we don't have an does exist. That's because we're using it a bit like a list, as I said, like this. So now we have selected the right customer. At first we know that the customer exists, and then we can select it. And I want the customer class to be able to make this new account, and it can't at the moment. So what we need to do here is make a create the account, and we want to create the account with these information up here. Type it in, type and balance and date. So we are in here. We can say accounts, they are here. .add. We have initialized the list in our constructor, so we are ready to receive accounts. Like this, and we want the type. And we want to insert the account number. Ooh, we haven't an account number. So how should we create an account number? I say we could do it from a random number, but still we need to make sure that the random number isn't in use at the moment. At the moment we don't store all of our accounts, and that's not a good thing. So what we want to do here is going back to the bank system in here and up here, and create a new dictionary for all our accounts. Like that. Then we can go into here, saying that we want to make a new account. What is it we want to do here? We want to select an account number. It was. Let's call it new account number. and we want the new random account number to be between those two. So now we have made a new account number, and then we need to see if it exists in our account. Contains key. Remember that we wanted our dictionary of all our accounts to have the account number as the key. So we can ask it nicely if new account number is existing. So I say if it doesn't exist, we'll put it to true, like this. Now we are ready to make a new account. We need the type, we have that. We need the account number. We have created that. We have the date, and we need the balance, like this. So we have all the information. So instead of making it this way, we're just entering it like that. And we need to store it on the all accounts. Like this. So the first thing we do when we want to create a new account is checking if the customer exists. If it does, create a new account with a new account number and send it over. It is angry at me here because I changed the input format. So let's go and change it to the right format, and we'll do that in the customer. Create account. We just send it out the reference for the account. So let's make it like this. Now we have the new account. Do we actually think it works? We can try to put in a breakpoint here. Then you'll learn a bit about breakpoints as well. And we can watch what happens when we go into this fairly complex code. So let's start our program. First we need to create a new user. Now let's create a new account. Enter the social security number. Enter the default balance. And the type, loan. And the date, it's a string, I can write whatever. So let's enter today's date in a Danish format, and we'll come to the breakpoint. We can see here that the new account is 0. Now where we are at the breakpoint, we can step through our code using the F11 key. So let's for now look at a variable of OK, it's false. We are going in here, see if we can calculate a random number. We can see here that we have made a connection to the random class. We have created a new account number. We ask here, does it exist? It doesn't, so we can say OK. And while OK is false, so we only went through it once, which will be the typical case And then we can add our new account. You can see we are up at the account class at the moment. At the account constructor we have a type loan. We have the default, the account number, a date, and the money of 100. Stepping through here, you can see here that we are creating the account event like this in here. Adding the account event to the account. Now we have made the account. We can see here that we have the account number and the actual account here with this number and type, and we can even scroll through to see our account events. And then we add it to the customer as well. We're back at the customer now. Sorry, I haven't added it yet. So we can look at all the accounts we have here. We can look at all our customers and can see that they have account. All the data on this account. Hitting F5 and going out of it, we can see it was a success. It is at this point that we'll certainly come to remember that we had a scenario about an employee who had a job to do every month. And we can even scroll in front to see that we have made a use case for it. But if we go to the class diagram, we can see here that we don't have any method for it yet. So we have made a mistake. Don't worry. When we look at the domain model, which focuses on the data of the program, we can see it will not affect our domain model. It will only affect the class diagram. So we are changing the class diagram and add the functionality to the code. No harm done. Let's go to our user interface and change it a bit here. Now we enter number 6 to end the program. Print account summary will be 5 for now. Changing the menu so it corresponds to it. We'll be making the functionality at the moment. We just need to, where was it? Please enter social security number. So we'll start out by saying, please select the customer. When we have selected the customer, we are asking the bank system to make this, and we'll just call it the same, giving it the social security number. we need to be sure that the customer exists. Therefore we do it like this, asking, does the customer exist? If it doesn't, we'll return false. It couldn't be done. What we want to do actually is returning the report, and the report will just say error. And for here, we'll just simply ask all customers dot like this to create like this. So if the customer exists, we'll just ask the customer to create this report for us. This way we make the customer class responsible for making the report. At first, we have just printed out the customer's name and address, useful information. Now we'll loop through every account that the customer has. For each account, let's call it A. In accounts, like this. So the customer has the responsibility of filling in the customer information, and the account class will we will hand the responsibility to the account class. So let's generate the method here. Oh, it went down here. So what we need first here is to make a string for this, and what we need to do here is calling the balance, displaying the balance, and we can ask for it here. We have the method calculate balance, but it's a number, it's a double, so we'll just call the toString function here. Sorry, like that. But that's not enough. We want also to add a new line here. We also need to put in if the account has been overdrawn. need to make this method, so we'll just do here. Then overdrawn. In here, no it hasn't. If balance becomes less than 0, return true. Like that. But that's not enough. We want to display everything that has happened on this account. So we'll say for each account event in account events report part plus equal account event, and we'll make the account event responsible for formatting its own data again, like we had done previously. So we'll just call it status this time and add a new line. Returning the date. Like this. We can go back here and we have returned this now. So down here we have made the entire part of the row of the report. So we can say return report part like this. And we can go to the customer here. Remember to add a new line. And we want to return the report that we had generated. Return report data like this. And in our system in here, we want to return it, so we just say here, return whatever the customer is returning. So the loop is quite simple, not very much code in each method. It all starts in our user interface in here. Now we are ready to print it out. So in here we're entering a social security number, and when we have entered the social security number, we just say print out the report generated by our bank system class in here. We can go to the bank system account here and say, for this, if the customer exists, you just return the report that the customer class has made. We execute this code saying that the customer has a name and address, we want to print that out, and for each account that the customer has, print out the report. What report? This report. The report of the balance and overdrawn and whatever has happened on this one. So there's not much functionality in each method. They are just split out where they belong, and then it's easier to read. Good architecture is the key here. We don't have the functionality for putting in money, depositing it, or to withdraw the money yet. But let's see if we can make the report anyway. we need to so we just tested if it was okay. We want to create a new customer, call her Jessie, this security number, and she lives here. Then we want to make a new account for her. The default balance, we can set it to 100, and it's a loan. And we can type today. It's a string, so the program doesn't care. And then we can say print it for this person. We have forgotten something. Somewhere we have an arrow here. So let's try it again. Create new customer, Jessie, social security number. Here, create new account for Jessie, default balance 100, loan today, and print for her. We can see up here that we have printed out Jessie here. Balance is 100. We haven't been overdrawn, and whatever has happened has just happened today. Of course, we can format this report to make it nicer, better looking. We can go in here and say that we want to start the report by 2 empty lines, for example, and after the address we want an extra empty line. We can go to this method here and say that when we have gotten the status, we want an extra line. And then we want to say report part plus equals events. Like this. Now our report will be a little bit better, nicer looking. Let's go to the user interface and see if we can withdraw some money. So let's make a withdraw method. Like this. What we need here is an amount of money and who should do the report withdraw. So let's just copy some of this code. And we can actually use it twice here. No, we have a better place to take this code. If I can find it. Here, default balance. Enter amount. Then we'll pass the amount. Like this. Now we have all the information. We can go to the bank system and say we want to withdraw the money that we have selected, and we want to do it, and we want the account number. Please enter like this. So now we have entered the information in the user interface, keeping those apart. Generating a little method here, saying that now we need to find, so we can copy a bit of this static void. We want it to be boolean to say if it succeeded or not. And we can let us inspire by this one and saying that if all accounts contains key account number. So if the account is here, we'll probably have a success. And otherwise we'll deduct it. Like this. But wait, this method doesn't exist. So we have to create it. We now know that we have an account. So redrawing money in the account class here is just to add an event. That's all it does. So all accounts events, add an event, and the new event will contain the data. We forgot to pass on the date, so I'll just say now. No, I'm not. I'm going to use system date time .toString, format like this. I put in the amount. Don't know what I hit there. Like this. Yes, now it works. So now we can withdraw some money. Let's try it out. Create a new customer. Create a new account for that customer. It's a loan. Oh. Create a new account for that customer with $100. It's a loan. It's got today's date, which is two months before our Christmas. And we are withdrawing some money. And we can't. This is really good software development. We have forgotten to print out what our account number is. So in the bank system here, where we created this account, up here, and we are returning true or false if it works or not, we'll just return an integer stating that as long as the account number is negative, it's actually giving us less code here, while the account number is negative, and it's only negative here. It's negative if it's contained. Like that. If the account number is in use, we'll set it to a negative number and then we'll doing the loop once more. If it's not in use, we'll not doing that and we'll come out here. Then we'll return the account number. Like that. And now we can go to the user interface, create account. Let's find the code. Here it was. And instead of the boolean here, we'll just say int account number. We can actually say that here, if account number is greater than 0, like this, else something went wrong. So let's try and create a new customer. Create an account for the customer. Making a, we can see up here that we have a new account number. I'll just write it down so I can remember it. And I can withdraw some money. Enter the account number 448849 and I want to withdraw 60. I can withdraw again 448849 and I can withdraw 60 again. Let's try and withdraw something that's not there. 555. It sounds like a Hollywood telephone number. And we want to withdraw 500. It didn't say something went wrong. We'll look at that later, but let's try and print out here for the social security number our report. We can now see a little bit nicer formatted that Jesse, who lives here, has a balance of 220 because we have entered 100 and 100 and 100. So we have an error more. And we can actually see here this is the date filled in by our system for us. But what we have forgotten here is that when we're making a new event to withdraw some money, we should withdraw the negative number. And the error once again were if we entered and if we want to withdraw some money here, withdraw money. So if it doesn't exist, we just return false, so in the user interface we didn't do anything there, which wasn't nice. Still, we couldn't do what we are supposed to do, but we should be told that we were not allowed to do what we did, what we tried. So it will be here, withdrawing money. There. Let's test it out. For the last time today, we'll be creating Jessie with the social security number. She lives here. We want to create an account for her with default balance. We can withdraw some money. $60, like that, and we can withdraw some money from our Hollywood phone number. 100, no, 1,000. It doesn't exist. Something went wrong, so now we get an indication that we entered something bad. We can try and print out for our social security number, seeing here that our balance is 40. We started out with 100 and we have withdrawn 60, so the 40 is correct and we are not overdrawn. We can actually withdraw some more money. What was the account number? $688,662. 688,662. Let's take out 100 and print a new report. Oh, customer didn't. I forgot wrong. That was the easy number. So we can now see that we have overdrawn like true. We are in with our balance is -60. And I'll just stop the program and stop the video for now, because what you need to do now is a little bit of code and then you can also enter the money. That would be your home assignment if you want to. Otherwise, I hope you enjoyed the video. It got a little bit longer and a little bit more complex than I wanted to, but I hope you can see a little bit about why we are modeling at first and what benefits it gives us, that we are aware of what we want our program to do before we actually code it. So bye from now, hope you learned something. Maybe we'll see each other again sometime.